Hey math fans, we're on section 5.2.1. Let's get started. The coordinate plane is separated into 4 quadrants or sections. Quadrant 1 is in the upper right-hand corner, and then 2, 3, and 4 go counterclockwise. In fact, I like to think about a clock, like where would 1 o'clock be? And that's where the first quadrant is, and it goes counterclockwise around. This section continues with our review of rigid transformations. And the first one is the translation. All the points in the pre-image are moved parallel to a given line. The translation below, we can see points A, B, and C are translated to A prime, B prime, and C prime, and then the image and pre-image are both congruent to each other. It's easy to see the translation because it's in the same orientation. In other words, it's pointing in the same direction. A little more review is the shorthand version of the translation. Remember, we're adding some number h to the x and some number k to the y. A reflection is a transformation where a mirror image is created. A figure is moved twice the distance from a line called the line of reflection, also known as a flip. In this section, I want to introduce you to some formulas. They've already kind of introduced them before, but officially, if you take a look down at the bottom here, there's a formula for reflecting. You take either the opposite of x or the opposite of y, or you switch the positioning of x and y depending on what kind of reflection you're doing. So that's kind of the shorthand formulaic way of doing a reflection. The reflection that confuses some people the most is, how do you reflect in the line y equals x? Well, it's actually pretty easy. You just switch the positioning of the x and y coordinate. In other words, if you were trying to reflect 1, 5, its reflection would be 5, 1. You just switch their position. And perhaps the most difficult is the rotation. Remember, a rotation is a transformation that turns a figure around a fixed center point, and each point in the pre-image is moved along a circular arc and determined by the center of rotation and the angle. Remember, it goes counterclockwise or clockwise. Counterclockwise is also known as a positive rotation, whereas clockwise is actually a negative rotation. This example right here is showing a 90 degrees counterclockwise rotation. And just like the reflection, it also has a formulaic way of determining where the image will end up. 90-degree rotation, you actually switch the x and y coordinate and make the y coordinate negative. 180 degrees, pretty easy. You just keep the x and y coordinates the same, but you take the opposite of both. And then you also have 270. Using the example 5, 1, again, if we were to rotate this 90 degrees counterclockwise, it would end up at negative 1, 5. If we did it another 90 degrees, it would end up down here at negative 5, negative 1. Again, following the formula of its original positioning. And then 270 would end up all the way down here. Here's some common errors and misconceptions. Just go slowly when you're doing these and you'll be fine. Here's the first example from the book. How far and what direction does point P, x, y move when translated with the function t, 24, 10. Remember, that's going to be adding 24 to the x value, adding 10 to the y value. So its official transformation is right here, x plus 24 and y plus 10 inside the parentheses. So if you had a point x, y, that's where it would end up. Example 2, using the definitions described earlier, write the translation of t, 5, 3 of the rotation are 180 in terms of a function f on x, y. Now this sounds really confusing, but what we're going to start doing is we're going to start making compositions of functions. In other words, we need to figure out what are we going to work with first. Now the word of the means that that's going to be happening first. In other words, there's going to be some point x, y where we're actually going to be doing the rotation first, and then we're going to translate. So remember, we work from the inside out. So I'm going to put the R180 x comma y on the very inside of the parentheses. And then as you can see on the outside of the parentheses right here is where I'm going to put my translation. And according to the formula I provided you with earlier, we're going to be taking the opposite of x and the opposite of y. So that xy will turn into the opposite of x, opposite of y here, and then we need to translate it. So now we have the opposite of x plus 5, the opposite of y plus 3, because it was a translation 5, 3. Final answer is down at the bottom there. Remember, we always work from the inside out. So always follow the words of the until you get to the very first, or actually I should say last of the, and that actually happened first. So example 3 is going to show you exactly what I was talking about in the last problem. We're going to follow the words of the until we get to the very last of the, and that's actually going to be the first thing. So watch closely. So we're going to write a reflection, r y equals x, of the translation 2, 3 of the, so we got to keep going until we get to the very last thing, and the very last one was the reflection in the x-axis. That's going to go on the very inside of the parentheses. And then the translation comes next. So we're working kind of backwards here from the inside out. And then finally, the first thing that it mentioned in the problem is actually going to be on the very outside of all the parentheses. So this right here is a reflection of the translation of the reflection. Start from the inside and work outward. Again, we're using those formulas that I provided with you with earlier. Here we're going to add the 2, and then we're going to add the 3 to the x and y value. Actually, it's the x and negative y value. And then finally, remember, a reflection y equals x is going to switch those positions. So notice how the x and y have been switched down here. Again, I'm just using those formulas that I provided you with on the first few slides. And that's going to do it for this section. We'll see you in class.